Question 4 is a logarithm question. So most people will find that 4a is quite manageable. If you look, it's only like a base 2 and a base 16. So we will always change a big base. We will change a big base to smaller base. So that's our guideline. So we wouldn't want to change a smaller base to a big base. So this part will be the change of base that you will need to do. So after the change of base, you need to simplify the denominator. Do show your working, because some of you might do mental in the denominator after your change of base. So after that, if you encounter something like denominator 4, you can multiply 4 on both sides. So multiplying 4 on both sides will get rid of the decimal, the fraction. Okay, from there it's actually quite easy. So you can visualize this as identical log. So can you see the two log are the same? So it's something like 4k plus k equal to minus 10. So that's like 5k equal to minus 10. So that's why it's like an identical log. You can do a substitution if you need. But this one is really simple. So you don't have to do a substitution. So after that, if you manage to isolate your log, don't forget that you can actually change your base, change out the log, change it back to indices format. So there will be some amount of indices that you need to apply here. So this one is quite easy. So just a change of base and then quite easy to isolate. So it's not very difficult. The challenging part is part B, because it involves some explanation, but you just have to follow the instruction and think along the concept of logarithm. So they give you a log equation and your job is to express z in terms of y. So expressing z in terms of y, you can process this as making z the subject. So you got to make z the subject, and of course the log will disappear. So I wanted to make z the subject, and I would like to throw away the log. So I got to simplify the log. So the first step that I did was I apply a logarithm rule, because there's if you still remember, you should be able to execute this rule by now. Log minus log, it will have become a fraction. So I'm applying this rule from here to here. And after that, I got a log on the left and a log on the right. So essentially that allows me to compare log on both sides. So I will compare the log on both sides. So once there are no more log, basically it's your algebra. It's your Sec 2 algebra where you make y the subject. Sorry, not make y the subject. You need to make z the subject. Okay, so you just throw all the cross multiply, it will be quite easy. So cross multiply, bring over all the z, and you will find yourself taking out a common factor. Then you can isolate your z. So follow the instruction. They will like you to make z the subject. And that is going to help you in the second part, in the explanation for this. Okay, so follow the instruction again. In the second part, there are two things for you to do. You got to state the range of z. So that's the first item that they are asking. And then you got to explain this. So that will be the second item. So in logarithm, the function that we are taking log on has to be positive. So if let's say the function is not positive, it will not be, it will be a math error. So that's why if I need to answer the first part, state the range of values of z. So if I want log z to be defined, that means it will not be a math error. Then I need this part to be positive. So that is the basic logic. And because I need z to be positive, and z is a fraction. So where do I get the fraction? I get it from the first part. So I need a fraction to be positive. So that means, right, my numerator divided by my denominator has to be positive. So this is the fraction that is representing Z. So for here, I already answered the first part. So this is the answer for the first part. For this part that the question one. And then I'm going to use this to further explain. So you observe the numerator. Numerator is a positive function. So I'm trying to explain that the numerator is a positive function. Hence, I will need the denominator to be positive as well. So if numerator is positive, denominator is positive, the whole fraction will be positive. And that is how Z can be defined. So I need to explain that the numerator is already positive. That's why I need the denominator to be positive as well. So, okay, when I need the denominator to be positive, I work out an inequality. I managed to get y less than 1. And subsequently, if you return back to your log, there is one log that involves log y. So again, it's the same idea. I need log y to be defined. So y has to be positive. So I have these two conclusions. So I have these two conclusions about y, and I combine the two conclusions, and that's how I explain. So the question is guiding you to eventually explain why the value of y will be between 0 to 1. So it started off with making Z the subject, and it started off by asking you to define the range of values of Z. And then from the range of values of Z, you twist it to the fraction that you've gotten. So the fraction has two components. I need the two components to be positive. Then the whole fraction can be positive. That's why I must explain that the numerator is already positive. This is an essential statement. If you do not write this, you will get marks deducted off. You will need to explain that the numerator is a function that is always positive. And then subsequently, I need the denominator to be positive. So the whole fraction ends up to be positive. And I also combine with the concept on log y. So I also need log y to be defined. That's why y has to be positive. So if you're thinking like, okay, if you successfully come to these two, okay, so if some of you might need, you can actually draw a number line. So less than 1, greater than 0, the combined answer will be from 0 to 1. Okay, it's not essential to show, but if you need this number line to help you to combine, then you can do it. Otherwise, you can combine just by looking at it. Okay, so look through. They are testing you the concept of log. So it's always a concept that you must know. The log function that we are taking has to be positive. So they base the idea on this and expect that you explain how do you define a log.